Hi, I'm Danica and I go to Monte Vista High School and I chose the wrist rehab device as my project. So for my second milestone, I actually changed the function of my accelerometer. So instead of monitoring the angle of my wrist, since the flex sensor already does that, I changed it so that it would monitor how many wrist turns you did once you inputted the command. I also added a piezo buzzer to buzz for different purposes, and I also incorporated the Bluetooth module that's built in on the ESP32. So for the demo, I can type in commands on my phone and it will tell the device what to do. So for example, if I type in menu, then it will it will tell me the commands that I can input. So for example, start monitoring will allow the flex sensor to start monitoring the angle of my wrist. So for example, if I do that, then on my computer, it says what angle the flex sensor is at. And if it gets past a certain threshold, then the piezo will beep like that. And if I type in stop monitoring, then it will stop the device. So even if I bend the flex sensor all the way down, the buzzer will not beep. This is mainly used for like sleeping. And you can also do wrist turns. This will prompt you to enter how many you want, let's say 3, and you can start calibrating. So once you stay at 0, once the pitch axis stays at 0 for 3 seconds, then it's calibrated. So now it's calibrated and you can do your wrist turns. And now you're done. So for the technical explanation, I added a piezo buzzer, which is an output device. So that means like you can tell in the code what the buzzer to do. You can say when it beeps, what frequency it beeps at, and how long it will beep for. And for the accelerometer, I didn't really change much. I still used the Magwick filter to convert the values of the accelerometer and the gyroscope into orientation along the roll, pitch, and yaw axes. Uh, Roll axis is like this, pitch is like this, and then yaw is basically up and down. Um, so basically for the wrist turns, I made it so that you have to stay at 0 along the pitch axis for 3 seconds, and then once you can start doing your wrist turns, you have to go down like this at a certain angle, and then it'll give you 2 seconds to go back up, and then if you do, then that is 1 wrist turn. And for the Bluetooth module, since it's already built onto the ESP32, I didn't really have to add the HC05 onto my breadboard. And basically, I just had to download an app on my phone and then connect the two serials together to wirelessly transmit information. So for the challenges, I had a few. The first one was that for some reason, when I was testing it the first time, the accelerometer wasn't outputting values correctly, and it was super slow. And also, after 10 minutes, my computer just crashed, and then my Arduino wasn't even uploading code. But then for some reason I realized there's 2 charging ports on my computer, and the one I was plugged into for some reason didn't allow the device to work. So when I plugged it into the other one, the device started working fine and my computer unfroze. The second challenge I had was when I was writing the code. Um, I tried to use the to lowercase function, and in Java that returns a string, but in C++ it's a void function, so it doesn't return anything. So when I was trying to set it to another variable, the code was giving me errors because it said that you can't really set a variable to void. When I realized that, I changed it and it works fine. And then for my last challenge, there is a function called toWrite, and basically it converts the string from ASCII numbers to actual text that you can read. But on the serial on your phone monitor, toWrite doesn't actually work. So you have to actually convert the ASCII numbers to real text, and then you can print it out on your phone. So I did that, and its values actually started printing out on my phone. So for what's next, I will solder everything onto a wrist compression sleeve and make sure everything works fine.